Okay guys, we're going to do number one, or at least questions very similar to number one. In each case, we're going to factor the equation and then solve for the x-intercepts. So, something I should point out, the entire reason we factor quadratics is to find the x-intercepts. So if you ever see a prompt that does not include these instructions, it just begins find the x-intercepts. It's important to recognize that factoring is still a key step. Factoring is a key step. I put it in the instructions, but it's just a step. Our real goal is to find the x-intercepts. And let's go ahead and get started doing that. So we have a quadratic. Let's go ahead and label our a, b, and c's. We have a equals 1, b equals 1, and c equals negative 30. And what we use a, b, and c for is to set up and solve what we call the diamond. Our b value, b is for bottom. And then our top value is whatever a times c is. In this case, negative 30 times 1, negative 30. Okay. To solve the diamond, what we need to do is ask ourselves the question, what would add up to 1 and multiply to negative 30? I'll give you a second to think about that. And your time's up. I think positive 6 and negative 5. Right? 6 plus negative 5 is 1. And then if we multiply them, we get negative 30. All right. What we're now going to do is factor our quadratic. Since we have a equals 1, we can take these two values and jump right to the finish line. X plus 6 for this value times x minus 5 for this value. And I feel like I always have to repeat, we can only do this because we have x squared. We'll look at the next one, it's going to be a little more complex. So this is the factored form for this quadratic function. It's f of x equals x plus 6, x minus 5. If you graph this function or you graph this function, you're going to get the exact same graph because they're equivalent. They're just written in different forms. To find the x-intercepts, we're almost done. We just take our function and set it equal to 0. And then if the product of two things equals 0, if x plus 6 times x minus 5 equals 0, then we know that x plus 6 equals 0, or x minus 5 equals 0. In either case, we have a pretty easy to solve equation. If we subtract 6 and we subtract 6, we get x equals negative 6 as one of our x-intercepts, or our solutions. And if we add 5 and add 5, we get x equals positive 5 as the other solution. So we're going to do the same thing, big picture, for the next problem. We're going to take the function and factor it, and then once we factor it, we take each binomial term and set it equal to 0 and solve. And that's going to be on the next screen. So if there's anything you want to write down or anything you want to hit pause on so that you want to start the next homework problem, hit pause because I'm about to flip. Okay, I'm flipping. We are flipped. So we have another quadratic function. We have the same instructions, find the x-intercepts by factoring. The one thing that's going to make this one different is we have 5x squared as a lead term. We still want to label our a, b, and c values. So we have a equals 5, b equals 11, and c equals 2. And we still want to set up our diamond. B is for bottom. And then a times c, in this case, we have 10, because of 5 times 2. We need to think what is going to multiply to 10 and add to 11. And in this case, it's a pretty obvious combination. 10 and 1. 10 times 1, 10. 10 plus 1, 11. Good to go. Check mark. All right. We cannot jump to the finish line. We have an a value that's different from 1. So we're going to kind of take the longer approach to factoring. We're going to use these two values as ingredients for splitting that middle term into two terms. 5x squared plus 10x plus 1x plus 2. So all we do is we take b and we split it into two pieces, a piece on the left and a piece on the right. What we're going to do now is identify common factors for the left half So let me go ahead and underline that in blue and identify common factors for the right two terms. So over here on the left, if we look at 5x squared plus 10x, 5 goes into 5 and 5 goes into 10. And also, x goes into x squared and x goes into x. So we have 5x as a common factor. If you divide by 5, you have 1. And if you have x squared and you divide by x, you're just left with x. And then if we take 10x and factor out 5x, we're just left with 2. Over here on the right side of the expression, we look at 1x and 2. They don't have anything in common. They do not have x in both terms. They aren't divisible by 2 in both terms, so the only thing they have in common is 1. Everything is divisible by 1, so that's their only common factor. And we take out that 1, we're just left with x plus 2. At this point, it's good to point out that, look, we have the exact same factor right here and right here. That's always a good sign. If you have a different term here and here, somewhere along the way you got off on the wrong track and you need to go back and figure out where your mistake is. Okay. Now we're going to write our final factored form. One of our factors comes from taking this term and this term, 5x plus 1. And then our other factor is the common factor that they share, x plus 2. So we have factored our quadratic equation. We still label A, B, and C, and we still set up our diamond. The only difference is instead of using these numbers for the final answer, we use them to split B into 2 pieces, then factor the left half, factor the right half, and then group the factors at the last step. Because we're looking for x-intercepts, we are not done. We need to set our quadratic equal to 0, which gives us 2 possibilities. Possibility number 1 is 5x plus 1 equals 0. Possibility number 2 is x plus 2 equals 0. And then in reverse order, if this is a possibility, and it is, we have x minus 2 as our solution. And then this one, we're going to have to do just a little bit of work. Subtract 1, subtract 1. So we have 5x equals negative 1. And then divide by 5. And divide by 5. And we have our other solution, x equals negative 5. So hopefully that helps with tonight's homework. One of them we can take the shortcut. One of them we cannot. We haven't done much practice where you cannot take the shortcut. But this is a good example of that. We use these diamond values for not the final answer, right? We don't see any 10s in our final answer. We don't use them for the final answer. We use them to split the middle, factor the left, and factor the right. If we go back to that very first one, right, our 2 diamond values were exactly what we used in the factor. And we could only do that because of that a equals 1. All right, I'll click on the next video, which is writing quadratic functions given a graph. It's a related idea, that's why I put it on the same assignment, but it takes some different steps.